Hello friends, welcome back to my YouTube channel. So today I'm going to discuss about maximum total damage with the spell casting. Okay, this is the lead code number 3186 number problem. Okay, so start with the definition. A magician has various spells. Okay, so you are given an array power which is name is a power. Okay, where each element represents the damage of spells. Multiple spells can have the same damage value. Okay, it is known that non fact that is a magician decides the cast a spell with the damage of power 5. They cannot cast any spell with the damage of power of I minus 2 power of I minus 1 power of I plus 1 power of I plus 2. Okay, so each spell can each spell can be cast only once. Okay, so return the maximum possible total damage that a magician can cast. Okay, so yeah, so if here I will consider this test case. Okay, so 1 1 sorry 1 1 3 4. Okay, so this type of test case we are checking here. Okay, so okay, so 1 1 1 1 3 1. Okay, so if we consider, okay, if we consider p of I is equals to 1. Okay, if we consider p of I is equals to 1, so we cannot consider this. We cannot consider p of I minus 2, p of I minus 1, p of I plus 1, p of I plus 1, p of I plus 2. Okay, so that means 1 minus 2 which is equals to minus 1, and 1 minus 1 which is equals to 0, 1 plus 2 with 3, and 1 plus 1 which is equals to 2. Okay, so if we consider p of I is equals to 1, so that means we cannot consider minus 1, 0, 3 and 2. Okay, so in this case, okay, so we are considering p of I is equals to 1, so that means we cannot consider minus 1, 0, 3 and 2. So here 3 is available. So here 3 is available. That means here we cannot consider in our answer 3. Okay, so we cannot consider 3 in our answer. So the our answer is 1 plus 1 plus 4, which is equals to 4 plus 5, 4 plus 1 plus 1, which equals to 6. Okay, the final answer is 6. So you will see here our final answer is 6. Okay, 6. Okay. So move forward with the second example. Okay, move forward with the second example. Okay, so yeah, here again mm, again see 7 1 6 6. Okay, so in this case, okay, so we are considering this case. Okay, so we are considering 6. Okay, so if I consider p of I is equals to 6. Okay, so that means 6 minus 2 which is equals to 4. Okay, 6 minus 2 which is equals to 4, 6 minus 1 which is equals to 5, then 6 plus 2 which is equals to 8, then 6 plus 1 which is equals to 7. Okay, so this type of question, okay, this type of values we cannot consider in our answer, final answer. Okay, so here if we consider in our answer is our value is 6. Okay, that means we cannot consider 4 5 8 and 7. So here 4 5 is not 4 5 and 8 is not available, but 7 is available. But so that is the reason we cannot consider 7. So our answer is 1 plus 6 plus 6, which is equals to 13. You will see here 13 is our answer. Okay. Okay, so okay, so we can consider 6. Okay, so we can consider 6. Okay, so for 7, so here again I am here I am very careful about 7. Okay, so we are here for 7 again I am calculating like this. Okay, so means how may which case is not covered is here. Okay, so for that reason we are I am going to sort this array. Okay, for that reason I am going to sort the array. Sort this array. So yeah, after sorting, so So the first of all cell is 7 7166. Okay, 7166. 7166. Okay, so if we compare, if we consider this case, okay, so we know, so we need also we cannot cover this time, okay, but we need to cover this also, yeah. So for this reason we can sort the array, as a so in ascending manner, okay, ascending manner. So 1 plus 6 plus 6, 1 6 6 and 7. Okay, so yeah, ascending order means smaller to bigger level, okay. So yeah, again if we consider this case, okay, so this case also covered, okay, this case also covered. Okay. hmm okay, then here I am thinking like so if we consider 7 means bigger value, so greedy approach can work. Means we need to maximize our answer. Yes, is that in our question is defined, return the maximum possible total damage that magician can cast. Okay, means for maximum return damage value. Okay, so we need to mm we are applying 7. Okay, so we are applying 7. Okay, so so if we consider 7, okay, so if we consider 7, okay, 7. Okay, for 7 means 7 minus 2, which is equals to 5. Okay, then 7 minus 2 is equals to 5. 7 minus 1, which is equals to 6. Okay, then 7 plus 2, which is equals to 9. Then 7 plus 1, which is equals to 8. Okay, so if we consider our p of I is equals to 7, okay, that means we know we cannot consider like this value. Okay, so here 6. Okay, so 6 we know we cannot consider 6 value. Okay, so we are excluding both the cases here, okay. So 5 not available, 9 not available, 8 not available. Okay, so that means we need only if I have only 1 and 7 both, there are two values. Okay, but okay, then and the answer is 1 plus 7, which is equals to 8. It is not not a fruitful answer. It is not a maximum answer. Okay, so yeah, in case, okay, if we consider this, okay, so our answer is 8. Okay, but we consider 6. Okay, so but we consider 6 means so we can generate our maximum answer. Okay, so here greedy approach will fail. Okay, so in greedy approach I can take maximum value. Okay, and for that maximum value my final answer is my final answer is minimum. So that's why I'm greedy approach is here fail. Okay. Okay. So now we are optimize this solution, we are for the optimizing this solution. Okay, optimizing this solution, optimize for optimization. Okay, so here first of all, hmm, here clearly need to say means here they will not clarify, but here in a question and they would means, okay, so 1 1 6 7 means we can consider this. Okay, so we can consider this. So that means we cannot consider this or this. Okay, so means we have option. Okay, so we have an option to select anyone. Okay, so mm, again I am telling you. Okay, whenever you will whenever you have any option. So okay, in that case maximum in any question. Okay, in any question recursion is most applicable, also most applicable, or in also and data structures part, in a DP section, very famous concept, 01 knapsack. Okay, 01 knapsacks. I know you all are familiar with this concept. Okay, 01 knapsack. Okay, zero one knapsack. Okay, it is very famous problem also. Zero one knapsack, so means is zero one knapsacks means, okay, so we consider, okay, 1 1 6 7. So here we will consider like a, so here we can, there are we can two options. Okay, so we are considering this or not, considering this or not. Okay, so one, so here one. Okay, then means we have two options. Okay, considering or not considering means including and excluding. Okay, so if we include this, okay, so means that means, okay, including, so means here 1 plus 1. Okay, means after okay, then again including this. Okay, then again I will check here. Okay, so we including this, so that means then next is 3, next is, okay, 3 again. Okay, so 3 can, 3 again, 3 can, 3 having two options, 3 having two options, including and excluding both the, so this type of so this type of problem is this. Okay, but here you will see, but here you can see again. So here 1 1 6 7. Okay, so here many values most of means many values are repeated, means they will have more than one frequency. Okay, more than one frequency. So basically here 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 we will use one which is here we need we need one data structure to store our numbers frequency. Okay, so here we will take map, hash map. Here we need to take in a C++ unordered set, unordered map, or we can say map. And in Java we need to use hash map. Okay, to store our numbers frequency. Okay, so here numbers frequency, numbers frequency, numbers frequency. Okay, so for 1 2 frequency available, and for 6 only one frequency available, and 7 for only one frequency available. Okay, so but these frequency how to use in our final answer. Okay, so for final answer, we can use like first of all we need to comparing, first of all we need to derive frequency. Okay, from this. Okay, we need to using you by using key, we need to derive a frequency, means our 2. Okay, into our frequency our keys value is 1, our keys value is 1. Okay, that means 2. Okay, that means 1 is repeating 2, 1 is repeating, 1 is 2 times in okay. So the answer in answer in answer we are adding 2. Okay. Okay. So basically this type of approach. Okay, so this kind of approach. So now we are jumping onto the code, and I will explain you how I can into code. Okay. 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 Here first of all we need to store our numbers frequency, so we need to take one hash map, okay, integer comma long, because we need to return long int answer. Okay, long, that means we need to store in our frequency in long format. Okay, so again then we can calculate here, our frequency. Okay, that means for any, so for 1 having 2 frequency, then 3 having 1 frequency, then 4 having 1 frequency. Okay, after that, okay, so after that 1 3 and 4. Okay, so we in all key sets. Okay, all key sets are stored in a list. Okay, as a variable. Okay, as a key, as a element. And then I'll I'm performing sorting operation. I am performing sorting operation. So 1 3 and 4. Okay, after that we need to calculate what is the size of our list size, or what is the size of our list. Okay, and then I am creating one dp array. Okay, then for initializing with and dp of I is equals to initializing with frequency of frequency dot get means with the help of keys. Okay, with the help of keys we need to we need we I will I'm deriving frequency and multiplying with key. Okay, means okay, our key is repeating how many times in our array. Okay, after that I'm applying for loop. Okay, so I is equals to 1 to n. Okay, so means here I will check here means frequency. Okay, so frequency into I means here I am calculating frequency and multiplying with our key means I will take here. Okay, I'm this is a take or not take means take here. Okay, then previous means okay, so previous. Okay, so we are finding rightmost approach. Okay, rightmost mm, means okay, so here I will check here. uh-huh. So you need to check here. Okay, so 7 1 6 7 1 6 and 6. Okay. mm. Starting in the index is the 0, starting index equals to 0. Okay, and ending index equals, let's suppose 2. So okay, so 0 1 2 0 1 and 2. So in this, okay, so we are finding rightmost element and return it here, right? We are finding with the help of binary search and return it the answer. Okay, okay, then here again I'm checking. Okay, so basically my again my previous value is valid or not. So this kind of I'm checking here. Okay, then my previous value is greater than or equal to 0. That means greater than 0 means greater than or equal to 0. That means this value is taking in our answer. Okay, after that I'm storing. Okay, in a take variable, and dp of I minus 1 means our last value and our current value. What was the maximum, and any maximum, then I'll store in my dp of I. Okay, then I'm returning dp of n minus 1. Dp of n minus 1 means okay, so here n. So what is the size of dp? So dp size is here. Okay, so 1 2 n 3. dp size is 2 means 0 1 and 2. Okay, 0 1 and 2 0 1 and 2. So this is the size of means n minus 1. N is equals to 3. 3 minus 1, which is equals to 2, means that is our final answer. Store is here. Okay. Okay, so in binary search you all need. Okay, you all are familiar with this binary search. Okay, means first index means left, right equals to end, then answer this. Okay, then left is less than or equal to this. Okay, so we are calculating mid. Okay, then finding my key, my mid value is less than or equal to values. That means our mid is our answer. Okay, then and after that I'll updating my mid I'm updating my left equals to mid plus 1. Okay, else r equals to mid minus 1. Okay, then I'm returning answer here. Okay, so this is a problem. Okay, today's problem. Okay, so yeah, thank you for watching.